Hello. So let's do another example. And again, what we're looking for to make sure that we can even do U-substitution is we're looking for a composite function. So we're looking for an inside function and an outside function. And then we're looking for the derivative of that composite function, or excuse me, the derivative of the inside function multiplied somewhere else in the problem. And here we just have a fraction, and I'll give you a hint. So oftentimes, not always, but oftentimes whenever you have a fraction, what happens is that the bottom is going to be our u. The bottom is going to be our inside function. And then the way to check that is to make sure that the top, or wherever else is multiplied in the problem, is a constant multiple of the derivative of your bottom. And so we're going to write down u is equal to the bottom of this function. U is equal to x squared plus 3x plus 7, and that's a guess. And then how we're going to make sure that that is in fact the u is we're going to take the derivative and see if the derivative is multiplied somewhere else in the problem, or if a constant multiple of the derivative is multiplied somewhere else in the problem. So now let's do du. So du is 2x plus 3 dx. And do we have a constant multiple of 2x plus 3 dx multiplied somewhere else in the problem? And we do, because 4x plus 6 is 2 times 2x plus 3. So what we can do is we can just multiply through by 2 in this equation down here. So we'll get 2 du is equal to 2 times 2x plus 3 dx. And so then that's going to be 4x plus 6 dx. Great. And I'm actually going to get rid of this just so we have more room. But yeah, so I just multiplied through by 2. Great. And so now we can identify kind of, this right here. So let's maybe use a different color. So this right here is going to be our u. So that's going to be our u. And then all of this up here, this 4x plus 6 dx, that's going to be our 2 du. And so let's write that. So then this is going to be the integral. On top, we have 2 du, and then on the bottom, we just have u. And all I did was, this dx is multiplied off to the side, but that's the same thing. We can kind of think, if we're kind of wondering how we got the 2 du on top, we can kind of make this a fraction. So this is dx over 1, and then to multiply these fractions, we just multiply the numerators together, and then the denominators together. All right, so this is the integral of 2 du over u. We can pull out the 2. So this is 2 times the integral of du over u. And then the antiderivative of 1 over u du, or du over u, that is ln of u. So this is going to be 2 ln of u plus c. And then our final step, like we've been doing, is plugging back in u. So then our final answer, 2 ln u, which is x squared plus 3x plus 7 plus c. Great.